Hello students, in this video class we are going to discuss a Java program which will take an integer number as input from the user, check and display whether the number is a prime number or not. Okay, so we have to take an integer number from the user and we have to check and display whether the number is a prime number or not. If the number is a prime number, we have to display it is a prime number. If the number is not a prime number, we have to display it is not a prime number. Now, let us discuss about the definition. Okay, definition of a prime number. A number which is divisible. A number which is divisible by 1, which is divisible only by 1, which is divisible only by 1 and itself is a prime number. Is a prime number. Okay. Now, looking at this definition, most of the students try to build a logic which is actually wrong. Now, what the logic is, listen. If a number, suppose the number is num, we have stored the number in variable num. If num modulus 1 is equal to 0, logical and means as well as that number modulus that number only is equal to 0, so it's a prime number. The students write it is a prime number, else not a prime number, else not a prime number. Okay, so this is wrong. Why? Because every number on getting divided by 1 give remainder 0. Yes or no? If we divide any number by 1, we will get the remainder 0. And if we will divide any number by itself, we will get the remainder 0. So in all the cases, we will get true and true here. So every time, whatever may be the number, we will get it is a prime number. It is a prime number. So this logic is wrong. Now we will focus on the other definition of prime number. What is the other definition of prime number? A number which has only two factors. Which has only two factors, that is 1 and the number itself. 1 and the number itself, okay, is a prime number. Is a prime number. For example, 7. So factors of 7, if num is equal to 7, okay, the number is 7. So factors of 7 are, see, 7 gets divided by 1 completely, yes. Can we divide 7 by 2? No. Can we divide 7 by 3? No. Can we divide 7 by 4? No. Can we divide 7 by 5? No. Can we divide 7 by 6? No. Can we divide 7 by 7? Yes. Okay, so please note down that the first factor of any number is 1 and the last factor of any number is the number itself. And if the total number of factors is 2, here the number of factors of 7, number of factors of 7 is equal to 2. Therefore, 7 is a prime number. Therefore, 7 is a prime number. Clear? 7 is a prime number. So, we will use this logic. In our program, we will try to count the number of factors of an integer number, which is entered by the user. After counting the number of factors, we will check whether the number of factor is equal to 2 or not. If it is equal to 2, it is a prime number, or else it is not a prime number. Okay, listen. Now how to do that? Listen. Suppose 7. Let us take the number 7. Num is equal to 7. Okay. Now we all know that the first factor of any number is 1 and the last factor of any number is 7. So what we will do, we will start from 1, then we will check whether 2 divides 7 or not, then we will check whether 3 divides 7 or not, then we will check whether 4 divides 7 or not, then we will check whether 5 divides 7 or not, and then we will check whether 6 divides 7 or not, and finally we will check whether 7 divides 7 or not. We know that 7 will divide 7, but we will go from 1 to 7. We will go from 1 to 7. So here we know the number of iterations, or we know from where to where we have to go. So we will be using for loop. Okay. So I is equal to 1 and I less than equal to 7. Clear? So let me use a for loop where I will start I is equal to 1 semicolon I less than equal to that number. Suppose the number is stored in variable num. It can be any number. Okay. It can be any number. Then I plus plus. Sir, why I plus plus? Because see, after 1, we have to check whether the number is divisible by 2 or not. After 2, we have to check whether the number is divisible by 3 or not. After 3, we have to check whether the number is divisible by 4 or not, and so on, till the number itself. Yes or no? So we have started I is equal to 1, I less than equal to that number, and I plus plus. Okay. And here we have to declare a variable NOF. NOF stands for number of factors and initialize 0 to it. Okay. Because listen, int num is equal to scanner object dot next int. Okay. So the user will give the value, it will be stored in variable num, and number of factor is equal to 0. Why 0? Because now the process of counting the number of factor is not started. Yes or no? So before that process of counting the number of factors, we have to initialize number of factor with the value 0. Clear? Now, within the for loop, I will check whether that particular number, that number can be any number. We are taking 7 as example. If that number on getting divided by I, if it gives the remainder 0, it means that particular value of I is the factor of num. See, first of all, the value of I is 1. Yes or no? So, I is equal to 1. That is 1 divide 7 or not? So, 1 7s are 7. What is the remainder? 0. That means, yes, the value of I is equal to 1. It divides 7. So if it is dividing, if that value of I is dividing the number, so we have to increase the value of NOF by 1. So just we have to use increment operator NOF plus plus. You can also write NOF is equal to NOF plus 1. You can also write plus plus NOF. You can also write NOF plus plus. Okay, no worries. Now listen. See, after if, I have not used curly braces because there is only one statement under if. Clear? Now just outside the for loop, let me check if number of factor is equal to 2, system dot out dot println, what? It is a prime number. What? It is a prime number. Okay. Else system dot out dot println, it is not a prime number. It is not a prime number. Clear? Clear, na? Okay. Now let me check this code with the value 4. If num is equal to 4. So NOF is equal to 0. Yes or no? I is equal to 1. And then the testing expression is I less than equal to num. What is num? Here we have taken 4. So 1 is less than equal to 4? Yes. If it is yes, it means true. If it is true, the control will go within the body of the loop. Num modulus I. What is num? It is 4. 4 modulus I. Let me write here. Yes. 4 modulus I means 4 modulus 1. 1 4s are 4. Remainder 0. Yes. So it's true. If it is true, NOF plus plus. So I will increase the value of NOF by 1. And then the control will go to the updation expression of the for loop I plus plus. So I will become 2. Then the control will again go back to the testing expression I less than equal to num. So 2 less than equal to 4, true. If it is true, num modulus I. What is num? It is 4 only. Yes or no? And what is I now? It is 2. 2 2s are 4. remainder is 0. Yes, it is 0. So NOF plus plus. NOF plus plus means NOF will become 2. And then the control will go back to the updation expression. Updation expression is I plus plus. So I will increase by 1. So it will become 3. Then the control will go to the testing expression to check whether the I value is less than equal to num or not. So what is the value of I? 3. 3 is less than equal to 4. Yes, it's true. If it is true, then it will check num modulus I. What is num? It is 4 only. And what is the value of I now? It is 3. So 3 ones are 3. What is the remainder? 1. So it is false. If it is false, this statement, which statement? NOF plus plus. This statement will not execute. Okay. The control will go to the updation expression I plus plus. So the value of I will become 4. Okay. Then the control will go to the testing expression to check whether the current value of I is less than equal to num or not. So what is the current value of I? It is 4. 4 is less than equal to 4. Now listen, 4 is not less than 4, but 4 is equal to 4. If any one condition is true, it will give true. And if it is true, the control will go within the body of the loop. Num modulus I is equal to 0. What is num? Num is 4. What is I? It is 4. 4 ones are 4. Remainder is 0. Yes or no? Yes, remainder is 0. So NOF plus plus, this statement will execute. So what will be the value of NOF? It will increase by 1 and it will become 3. Then the control will go to the updation expression I plus plus. So it will become 5. Okay. Then again, it will go to the testing expression to check whether the current value of I is less than equal to num or not. So what is the current value of I? It is 5 less than equal to 4. So 5 is less than 4? No. 5 is equal to 4? No. So it is giving false. It is giving false. If it is giving false, the control will come out of the body of the for loop. And here we are checking. What we are checking? NOF, whether NOF is equal to 2 or not. Yes or no? So what is the value of NOF? It is 3. It is 3. So 3 is equal to 2. It is false. If it is false, it is not a prime number. Clear? Yes or no? So what are the factors of 4? What are the factors of 4? Factors of 4 are 1, because 1 divides 4, 2 divides 4, and 4 divides 4. So there are 3 factors. But what is the condition? If number of factors is equal to 2, not more than 2, not less than 2, then only we can say the number is a prime number. Clear? So this is the logic. Now let me write the program for you. Listen. Open BlueJ. Let me delete all these classes. Yes. New class, give any name, click on OK button, double click over it. Control A, backspace. Control minus. P. Let me import. import import java.util.scanner scanner public class prime number checker or tester. public static static void void main, then capital str ing string array space args, then control shift I and create the object of scanner scn equals to new scanner. Okay, and then system.in. Let me display one message, system.out.println, enter an integer number, int num is equal to scanner object next int. Okay, then int NOF is equal to 0. Okay, now I will use a for loop. Int I is equal to 1. Why? Because the first factor of any number is 1 only. Okay, and then I less than equal to num. Why less than equal to num? Because the last factor of any number is the number itself. Okay, I plus plus. Now within the for loop, I will check if that entered number on getting divided by the value of I If it produces the remainder 0, it means I should increase the value of NOF by 1. Okay. And here I will have to check if NOF is equal to 2, system.out.println what? It is a prime number. It is a prime number. Now let me copy this message. Okay. Else it is not a prime number. It is not a prime number. Control Shift I, Control K. Illegal start of expression, yes. NOF is equal to 0. Okay, NOF is equal to 0. So no syntax error. No syntax error. Now enter an integer number. Suppose 2. So 2 is a prime number because it has two number factors. One is 1 and the other one is 2 itself. So it is a prime number. Okay. Now let me give 1. 1 is not a prime number. 1 is neither a prime number nor a composite number. Why? Because the only factor of 1 is itself 1 only. So here number of factor is equal to 1 only. But we need number of factors is equal to 2 in case of prime numbers. It should not be more than 2. It should not be less than 2. So in case of 1, it is coming. It is not a prime number. It is not a prime number. Yes or no? See, when you are entering the value of num is equal to 1. So what is happening? Okay, let me show it to you. Close it. Where is the program? Yes, this is the program. Listen, when we are entering when the user is entering the value 1, okay, so num is equal to 1. Number of factor is equal to 0. What is the value of I? I is equal to 1. Then the control goes to the testing expression to check whether I is less than equal to num. What is num? Num is 1 only. So 1 is less than equal to 1. See, 1 is not less than 1, but it is equal to 1. So it will give true. If it gives true, the control enters within the body of the for loop. And here we are checking num modulus I is equal to 0. So what is num? 1. What is the value of I? 1. So 1 ones are 1, remainder 0. Yes, it's true. So NOF plus NOF is 1. Then the control goes to the updation expression to increase the value of I by 1. So it becomes 2. Then the control goes to the testing expression I less than equal to num. So what is I? 2. 2 less than equal to num. What is num? It is 1. So 2 is less than 1? No. 2 is equal to 1? No. So in both the cases, it is giving false. It is false only. If it is false, the control is coming out of the body of the loop, and here it is checking number of factor. What is number of factor? It is 1 only. So 1 is equal to 2. So it is false. If it is false, this part will not execute. This part will execute. It is not a prime number. Clear? Clear or not? Okay. Now let me give 7. Let me give 7. 7 is a prime number. Okay. Let me give 29. 29 is a prime number. Clear or not? Okay. 97. It is a prime number. So this is how we can check. Now what is the other way? There is another way. Okay. How to check? Now listen. What is the other way? See. If the value of num is 7. If the value of num is 7. And if you are starting the value of I from 2 to 6. So 2, 3, 4, 5, 6. Okay. And if you are checking whether 2 divides 7 or not. No. Yes. Listen, take the value of NOF is equal to 0 only. And if any value from 2 to 6 divides the value 7, we have to increase the value of NOF. So 2 is not dividing 7. 3 is not dividing 7. 4 is not dividing 7. 5 is not dividing 7. 6 is not dividing 7. Okay. So NOF should be equal to 0. Okay. So we can write, yes, it is a prime number. Now listen. For, okay, let me take that number from the user. Int, that number is equal to scanner object dot next int dot next int number of factor is equal to 0. Okay, number of factor is equal to 0. Then for loop int I is equal to 2. I less than, not equal to, only less than num, because we are excluding that number here. Yes or no? We are starting from 2 till what? 1 less than that number till 6. So less than num. And then I plus plus. Here let me check. If num modulus I is equal to 0, system dot out dot no. If num modulus I is equal to 0, just increase the value of NOF by 1, NOF plus plus. Now outside what we have to check? We have to check NOF. If NOF is equal to 0, we can write system.out.println what? It is a prime number. Yes or no? It is a prime number. It is a prime number. Else system.out.println, it is not a prime number. It is not a prime number. It is not a prime number. Clear? Because see, prime numbers have two factors, yes or no? One and the number itself. And we are not considering, or we are not taking one and that number in this case. We are starting from 2 till 1 less than that number. In this case, when num is equal to 7, we have started from 2 till 6. So if NOF is equal to 0, okay, if NOF is equal to 0, I mean, it is not increasing. It is remaining 0 only. It means it is a prime number. It means 7 is not getting divided by any of the numbers from 2 to 6. So in this case, when you are starting the value of I from 2 till 6, in case when num is equal to 7, that is I less than num. In this case, if NOF value remains 0, we can tell it is a prime number. Else it is not a prime number. Yes or no? So like this, we can also write. But it will create a mistake, or it will create some issue. What is that issue? I will tell. Listen, let me write this. So I will start I is equal to 2, I less than num, I plus plus, and here I will write NOF is equal to 0. It is a prime number, or else it is not a prime number. Okay, listen. Right click, main method, okay. Enter an integer number. If I press 2, it is a prime number. It is showing correct. Okay, enter an integer number, suppose 3. 3 is a prime number. It's correct. Okay, 4. 4 is not a prime number. It's correct. Then, sir, where is that mistake? Sir, if I give 7, it is a prime number. So the program is correct. But you were saying that it is not correct. There is some issue within the program. Yes, there is one issue. What is that issue? The issue arises when you give the value 1. And we all know that 1 is not a prime number. 1 is not a prime number. 1 is neither a prime number nor a composite number. But in this case, it is telling it is a prime number. Why? Now let me tell you why. Why it is telling. Listen. Very, very important. Very, very important. Listen. Suppose the user has given num is equal to 1. Yes. So the value of num is 1. Okay. Number of factors equal to 0. Number of factors equal to 0. I is equal to 2. I is equal to 2. Then the control goes to the testing expression. I less than num. What is num? I less than 1. Okay. So what is the value of I? It is 2. 2 is less than 1. At the very first case, it is giving false. Yes or no? 2 is not less than 1. False. If it is giving false, at the very first stage, the control comes out of the body of the loop. I mean, the control just skips the for loop and comes out of that. NOF is equal to 0. Yes or no? Here NOF is equal to 0, 0 is equal to 0. So it is showing true. If it is showing true, this part will execute and this part is not executing. This is the reason why this code is correct in all cases, but this code is incorrect for the value 1. Now, how to resolve this issue? The question arises how to resolve this issue. So we can write what? We can write here if num is equal to 1, system.out.println, system.out.println, it is not a prime number. It is not a prime number. Okay. Else, so I have put all the coding within else. Now you can see here, control K, no syntax error. Close main method. Okay. If I give 1, 1 is not a prime number. Now why? See, the user is giving 1. And at the very first stage only I am checking. If the value of num is 1, directly print it is not a prime number. So the else part will not execute. If the value of num is not equal to 1, then only the else part will execute. And in the else part, again, we are checking for that number. So this is the This is the way to deal with it. When you have started the value of I from 2 till 1 less than that number, that is less than num. Okay, clear now? But what I will prefer this technique where the number of factor is equal to 2. All of you use this technique. Okay, start the value of I from 1 till that particular number and count the number of factors. If the number of factor is coming 2, directly display it is a prime number, or else it is not a prime number. Clear? Okay. Now listen, how to do this program in another way. Okay, so here let me not write if. Okay, let me not write else. Control Shift I. Okay, num. Let me start the value of I from 1 and less than equal to num. If number of factor is equal to 2, it is a prime number. Okay, now let me check whether it is working or not. There is another way. Just wait. I will tell. Suppose 1, yes, 1 is not a prime number. Very good. Then 2 is a prime number. Then 3 is a prime number. Now let me check for 4 is not a prime number. So it is fine. Now there is another way. What is that way? I want to divide the task. Okay. Now the main method will just take the value from the user. And for checking purpose, we will assign this task to some other method. Okay. Main method will take the value from the user. And the task of checking whether the number is a prime number or not, we will assign this task to some other method. Clear? Okay. Now listen, how to do that? So here I will use if, and I will name that method is prime, is capital PRIM, is prime, and I will pass that number. Okay. So within the parenthesis of if, we can write directly true or false. We can write a relational expression, which will be having some relational operators. Okay. And the expression can contain some relational operators, logical operators, that thing. Ultimately, we need true or false. And within the parenthesis of if, we can call a manipulative method. Now, manipulative method is that method which gives you either true or false. Okay. We can call such methods. Clear? Is prime none. If this method is returning true here, I will display system.out.println, what? It is a prime number. It is a prime number. It is a prime NUMBR. It is a prime number. Else, ELSE, else system.out.println, it is not a prime number. It is not a prime number. Now all this coding, okay, I will put in the block of is prime method. Now check here, while calling the is prime method, you are passing that number. So this method has to be a parameterized method. This method will accept a number, integer number, say n. Okay, if you're using n, so within this method, everywhere, wherever num is written, let me make n. Let me make n. Okay, yes, now it's correct. Now, what will be the return type of this method? Boolean. Why? Because this method has to return true if the number is a prime number. And this method has to return false if the number is not a prime number. Clear? Now let me make it static. Let me make it static. Now what is the reason? As we are calling is prime method from within the static main method directly without creating object. So I'm making it static. Clear? Now let me make it public. Okay. Control Shift I, then curly bracket start, Control Shift I, and in place of printing, I will have to return. Okay, RETURN, return true. True means yes, the number is a prime number. Else we have to return false. We have to return false. RETURN, return FALSE, false. Clear? Control Shift I. Control K, no syntax error. Is it clear? Okay. Clear, na? How this is working, listen. How this is working. Listen, huh? See, if the user has given the value, suppose 3. Yes, 3. Okay. So you have passed the value 3 while calling the is prime method. This value 3 will be received by the parameter n. So n will have the value 3. Okay. And this method will evaluate by this process. I have already discussed, yes or no. So we all know 3 is a prime number. So this method will return true. Why? Because number of factors of 3 is equal to 2. Because see, factors of 3 is equal to 1 and 3. So number of factors of 3 is equal to 2. So here we will get, yes, 2 is equal to 2. Okay, so it will return true. Now true will be returned where? At this part. At this part we will get true. If it is true, within the parenthesis of if, else part will not execute, if part will execute. So it will show it is a prime number. Clear? Clear or not? Now let me compile, no syntax error, close. Right click, main method, okay. If I give 1, it is not a prime number. It's correct. If I give 2, it is a prime number. If I give 3, it is a prime number. If I give 4, it is not a prime number. Clear? Clear, na? Okay, so take the screenshot of this program. Okay. Now take the screenshot of this. Now please practice this is prime method because this code will be used in some series program, pattern program, and many other programs. This is a very important method. So I want you all to practice this method as much as possible. Okay. So thank you so much for watching this video. Bye-bye. Take care.